Okay, so that's enough parsing HTTP manually. It is a brutal process, very painful, very complicated. There's a lot of edge cases. It's just not something in general we would like to do, and luckily we don't have to. Go is designed for network applications and particularly for web apps, and so it has a wonderful HTTP library built in. So we can see that library. It's net/HTTP. Okay. HTTP provides HTTP client and server implementations. We're looking at server. We'll talk about client later, maybe. And the basic idea is that we can use this to create an HTTP server. Remember, it's still on top of TCP, but this guy is way easier to use than the other one, than doing it manually. So let's look at an example to see how you use it. I'll call this HTTP example 2, and we'll create a main Go. Something is screwy with my editor here. So what we can do is we can say HTTP, so you import net/HTTP. And it has a listen and serve function. You can probably guess what this does, but let's go look it up just so we can see it. Listen and serve. Listens on a TCP network address and then calls serve. Okay. So we give it a TCP address, colon 9000 again. And then it takes, as the second argument, a handler. What is a handler? Handler is this interface. So let's make something that implements that interface. Okay. So I'm going to create a type myHandler. Normally this is a struct or something. I'm just going to make it an int. Okay. And then I'm going to have h star myHandler, or not a star, just regular myHandler. And then I'm going to copy that method definition right here. So I create a new type. There's a receiver. I add a method called serve HTTP. Now let's name these variables. I'm going to call them res and rec. That's just what I tend to use. Other people use a W here. That's very common too. And an R for request. I kind of just like res and rec. And so let's go look at the definitions of those. So actually, in its current form, we have implemented the interface. Sorry, these should be HTTP. And so now we would pass it in here. So let's, var h myHandler. And now I pass it in. And what this does is it starts a TCP listener, like we've been seeing. And then it's going to send any HTTP traffic to this function. Well, to this interface, which happens to be this function. Okay? So it's going to call serve HTTP anytime a request comes in. And that's what this is going to be. And then we use response to write it out. So let's just see what happens when we run this.
Does it run ready to go? Separate go?
It does. It runs one Go routine per request. So go install HTTP example 2. So now it's running. We go over here, localhost 9000. We don't get anything. Why don't we get anything? Because I didn't do anything, right? So we should make this guy do something. Everybody understand why I didn't do anything? So the way we can do that is if we go look at the definition of response writer, we will see that it is an interface. It has header, write, and write header. And so that looks familiar, doesn't it?
So the writer interface?
Yeah, so response writer is an IO writer, which means you can use a response writer anywhere you can use a writer. Which means all the stuff we've been doing so far, we can continue to do. I can say io.write string, hand it the response writer, and give it a string. Now, if we save this, we'll see hello world over there. All goes well. Okay.
For you to just sort of, I always want to like step through the code. It really helps me just sort of like talk it through. And I was noticing that Bob, you're doing that. Is that helpful to you too, Bob? Just sort of like talk through and make sure you understand the lines or whatever. It's a func name, and then you're creating a variable age, which is a type my handler, and that is also what would you say, extends an int, or what would be the right word on age?
It is an int.
It is an int.
Its underlying representation is an int.
Yeah, okay. But it's also its own type, right?
Yeah, it has its own type.
And int's a type, that's where it's a little fun.
So how many bytes does H take up?
If it's an int, it depends upon your OS.
Right. So in our case,
64 on most computers
8
today.
bytes.
Oh, 8 bytes. 8 bytes, 64 bit. And then for my handler, you have the receiver attaching the serve HTTP on line 10 method, which makes it implement the
handler interface.
The handler interface.
Right, because if we go look at handler again,
Yeah.
it just has to have, whatever the type is, the type has to have this method. Okay.
Yeah.
So we implemented that by creating this method.
Takes this and takes that.
And that allows me to use it.
And then you can use response writer and listen and serve if he takes in the path or
The
what
port
would be
to
that?
bind, the address to bind.
Say that again?
The address to bind.
So address to bind.
Without a left part of the
Yeah.
colon here,
Yeah.
that means every address. So if so the other way you often see this is localhost colon 9000
Yeah.
or 127.0.0.1.
Yeah.
And what that's saying is only traffic that comes from my local computer. This means traffic that comes from anywhere
Okay.
on port 9000.
And so when traffic comes in to listen and serve, we're going to send it to H. And H is the variable, and it has the handler attached to it. And so then when traffic comes in, the handler automatically fires, because that's what handlers do. Is that right? That's a good question.
Inside listen and serve, it says go h.serve HTTP.
Okay.
Because this is an interface that has the serve HTTP method in it.
Okay.
So it just calls this method, that's what it
Okay.
does.
Okay. Okay.
It has nothing to do with the names or anything. It's because it has this method, that's why it works. We could call this foo, and it would still work,
Okay.
right?
Okay.
The RES and the REQ.
So RES is an HTTP response writer. REQ is a pointer to a request. And so request has information about the request. Res here, the response writer, is how we communicate, is how we send data back to the response. And so I'm using it as a writer. I'm writing a string to it. And that causes it to create a response, an HTTP response, and then I see it in my browser. Okay. So what it has done is it's not just writing this directly. The first thing it does is writes all the headers. So it writes, remember how we had to do that? The status line 200 OK, and then it writes, content length and et cetera, et cetera. It writes all the headers for us. And then it writes out string.
This still needs to happen, right?
So it writes it for us, and we can see that with curl. So here's the response. It added a date and content length and the content type for us.
And it has ways you can add that in if you want to change it.
Yeah, so let's see that since we asked about it. If you go back to response writer, we'll see that it has a header here. It also has this write header. And basically the way this works is the first write causes this to happen, unless you've already done it. And write header, the int here, what do you think the int here means? Status code. So that'd be 200.4.4, the status code of that, with status code. So with you call write header, and it causes all the headers to be written with the status code. The first time you call write, it's going to do that for you, and it says that. Write calls write header before writing the data. So see, in general, you rarely have to do this. You do this if you have to change the status code. If I want to say there was an error or something, I might do this. But in general, we just use write. Or in fact, we actually usually work at a level above this. We treat it like a writer. I use like IO write string or something. We'll see templates later. You might just render a template directly to it. We'll see how you can serve a file later, and you can just copy a file into this. But we generally use this, and it does all the other stuff for us. Okay. But header, so we call this, and it returns a header, and then we can do stuff with header. So look, header is just a map of string to slice of string. So that looks very similar to the header I created in the other example, except this one can have more than one value, but it's basically the same way. And generally, we use these guys to do it. And the reason we use these is because in HTTP you can have, it doesn't have to be case sensitive, so you can have CON, content length, but the L could be capitalized, like this could be length, And so we generally use these guys so that it does the canonical header, right? Makes it the way that everybody expects it or whatever. So we just use, instead of using the header directly, we use get and set. So I'll show you that. It's really easy. You just say res.header, now it's a method, so we call it like that, and then set. Let's do content type, because we've done that before.
Make content type units, plain units. Plain-units.
And so that would set the content type of the response to plain text. Now, it does need to happen before this guy. Because as soon as this happens, the headers have been written. And so you have to set the headers before you write anything to the response.
You have to set the size of the body.
So it tends to do that automatically. And I think, I don't remember exactly the details, but I think if it's too big, it switches to transfer encoding chunked. So generally you don't have to worry about it. It'll do it for you. But I think it also actually we can look at it. It's kind of interesting. There's a lot of cleverness in this code, which makes it easier to use. And so let's look at the response writer here. Where is the definition? Here we go. He does all this other stuff. Well, anyway, you could dig in here and spend hours studying this code to understand all the things it's doing. But I think it has some things where it can detect whether it's seekable or not, get the length that way. But in general, it just does the right thing. But you could, if you had to, add it yourself and maybe we can fix it, but usually it just does the right thing. It even does this part for you. It adds a content type based on the initial 512 bytes of the data written. So in other words, if I write out like angle bracket, exclamation point, doc type, it's like, oh, that's probably HTML. So I'm going to set the content type to text HTML. So it's a bit clever that way. Okay. So in general, you don't even have to do any of this, right? You just set it and you're done. But if you needed to set headers, you can do it that way. Okay? You need to set. To get headers, we use the request. So let's look at that. Everybody understand response? Any questions about response? It's pretty easy. Okay.
Maybe just scratch that up, so I'll put it as a record for everybody. ID.
I mean, all this stuff is, there's tons of examples in the docs for these guys. So, even at the top of the page, I think there's examples for the server. But we'll see more. So request. So if we go to type request. A request, so it has these fields, like method, that's get, post, put, like we saw before. The URL, which is a nice wrapped object that gives you these nice parts of the URL. And they describe what those are, scheme, colon, // possibly user info, the host, the path, possibly a query, possibly a fragment. And then, the photo. We also have header. So how do we get the value of a header? So what if I want to see the accept header? I say rec.header.get accept. And I can return return that right here. Let's just see what it was. Oh, I downloaded it. Let me curl. */*. That's what accept was passed in. So maybe that's not useful, that interesting. Maybe we can see if well, no, that's not going to be set. But anyway, there could be lots. We could just, sometimes for debugging, you can just print line the whole header. You can just do this, okay? And in general, print line works with all kinds of stuff. So you can just pass it things, and it usually prints out something that's kind of meaningful, which can be useful for debugging. So now I can see there's all the headers that were passed in. The user agent curl. So if I hit it from the browser, the user agent will be different. All this other stuff that it passed in. Here it is, prefer, what's passed in. So, and misspelled, as it should be. So that's how we can get the headers. There's a lot of other stuff on the request. So if you need some particular part of the request, you can get it from here. Like I said, there's a transfer code and there's other stuff too, like the host, the form stuff. We'll see some more of the examples of how to do these things later. But that's the basic outline is that you get your request and response, and you write to the response. So let's do the first example and the second example. So the first example is hello world. Just make an HTTP server that prints hello world. And the second example is echo. And I want it to echo the URL. So what we did manually with the TCP guy, I want to do it now with the HTTP library.